Welcome back to my computer learning series, and I am owner of FFBMD Inc. or FFBMD channel, YouTube channel. And in this series, as you know that earlier this series was done by Get Willy, Get Handler, and Jack Handler, and all now these all three people are now in their own country with a hike of 1,000 times in their salary, and the lecture left by them I am going to complete it. So let's talk. I also like to tell Jai Sri Ram, Jai Sitaram, Jai Hanuman, Jai Bajrangbali, Om Namah Shivaya. In the previous lecture, we see different types of programming and the fundamental concept of OOP, that is object oriented programming. Now let's see the key elements of object oriented paradigm. Based on the previous description, we summarize the key elements that a programming language must have for categorization as an object-oriented language. First, abstraction. Abstraction means that an object's characteristics are broken into manageable chunks as defined and documented in its class description. Encapsulation. Encapsulation stipulates that code and data are stored as one unit. Encapsulation also enables selective or total information hiding, since it can make portion of the code and data inaccessible. Inaccessible from outside the unit. Modularity. Modularity defines the unit reuse. These units group abstraction together. Next one is a hierarchy. It allows an object's behaviors to be refined without recording of the parent objects. Some object-oriented languages allow an object to have more than one superclass, a feature that is known as multiple inheritance. Inheritance hierarchies enable ranking and ordering of abstraction. Meshes. Meshes, similarly in use to function calls, are requests to perform an operation on an instantiated object. So these are the key elements of an object-oriented paradigm. Now let's talk about some high-level language. Since the first high-level language in early 1950, today there are more than 1,000 high-level languages. Only a few of them have been truly significant, and even fewer have been widely used. Some popular high-level languages are briefly discussed in the next section. The primary objective here is to provide some insight into these languages. So let's try to investigate some high-level languages. The first one I would like to choose is the Fortran. It is a high-level language. The Fortran means Fortran is written in capital letters. The Fortran stands for Formula Translation. It is one of the oldest high-level languages. It was designed to solve scientific and engineering problems and is currently the most popular language among scientists and engineers. John Bacchus and his team at International Business Machine Corporation developed it originally for its 704 computer in 1957. Since then, it has undergone several revisions and has been evolving into a wider and more useful language with time. As in the earlier lecture I said it, I don't like to wander and make a video lecture. So I am staying at one place and discussing the lecture. But my employee Get Handler and Get Willy and Jack Handler, they like to move and make lecture, but I don't like this type of moving and wandering. I am staying at one place and making and giving you the lecture. Now come to the point. The original version of Fortran developed by Jan Bacchus and his team was soon followed by a version popular as Fortran 2. The next popular advanced version was Fortran 4. In order to make Fortran language machine independent, American National Standard Institute ANSI standardized Fortran 4 in 1966. With this, Fortran became the first standardized language. In 1977, an updated version of Fortran 4 called Fortran 77 was released and standardized by ANSI. This version was oriented toward a structured programming approach and had several new features of this. Fortran 90 is the latest version of Fortran standardized by ANSI. It again has many new features as compared to Fortran 77. As Fortran language is oriented towards solving problems of a mathematical nature, it is an algebra-based programming language. An algebraic expression or mathematical relationships can be expressed easily as a Fortran instruction. For example, A equals to B plus C minus D. The nature of Fortran program with a simple program to compute and print the sum of 10 numbers. Notice that a Fortran program consists of a series of statements for input, output, calculation, logic comparison, etc. The word capital read, capital write, capital do, capital continue, capital stop, and capital end, etc. in the statements mean exactly what one would expect. A sample of Now let's discuss a sample of Fortran program. For example, in the first line C, Fortran program to compute. Second line C, all letters are in this is in capital. Second line C, the sum of 10 numbers. Third line sum equals to 0. Fourth line do 50 I equals to 1 comma 10. Read 5 comma 10 n. Sum equals to sum plus n. Next line 50 continue. Next line write 6 comma 20 sum. Next line 10 format f6.2. Next line 20 format 1x. The sum of the given numbers equals f10.2. Next line stop and next line in.